Okay, class. We're starting section 1.3, slope of a line. The slope is a measure of the steepness of a line. To read slope, imagine traveling along the line from left to right. It's the same as reading a book. Lines that are increasing have blank slopes. They have positive slopes. And here's an example of a line that's increasing. If you notice here, when you go from left to right, the line is going up. Again, everything is based on going from left to right. Lines that are decreasing have negative slopes. If you notice from left to right, you see that the line is going down. Now, we come down here to horizontal slopes. Horizontal lines have slope which is equal to 0. They have a 0 slope. Now, vertical lines, and we know, first of all, horizontal line, we know we go from left to right, and vertical lines goes up and down, and it's an undefined slope. And this also denotes that all of these lines are infinite. Okay, now we scroll down, scroll to the next page. Method number 1 for finding slope. As you move from one point on a line to another point on the line, the slope can be found by using the fact that slope is equal to rise over run. Now there's one other thing. Remember, we also use the variable m to denote slope. So we have m is equal to, which is the slope, rise over run. Now the rise goes up and also down, which is your vertical change. Now your run goes from left to right, well, it actually goes left or right. And this is your horizontal change. Now, putting this in terms of ordered pairs, we know when we're talking about vertical change, we're talking about y values. So this, your rise deals with your y values. And then for the horizontal change going left to right, we know that that deals with your x values. Now we come down here to example 1. It says a truck driver has to choose which mountain pass he will take. Pass A has a 20-foot climb for every 100 feet horizontally. Pass B has a 15-foot climb for every 160 feet horizontally. What is the steepness, often called grade, of each pass, and which one should the truck driver take? Okay, so now this is what we would do. We will find the slope of pass A, which is equal to, now remember, we're doing rise over run. We're doing the vertical change, which is the climb, the 20-foot climb. So that would be 20 feet all over the horizontal change, which is 150 feet. Now, we can simplify out feet. And 20 divided by 150, if you put that in your calculator, that will give you 0.13 with the 3 repeating. So that is the slope. The next thing we would do is the slope of pass B. Now again, we have a 15-foot climb, which is your vertical change, and 160 foot horizontally, which is your horizontal change. Now when we simplify this here, we would get 0.093. So when we look here, we look and see this here. If you're driving a truck, you want to go on the path that's least steep, which means it has the lowest slope. Since path B has the lowest slope, that is what we would take. We would take path B because it's less steep. Okay, now we scroll down here to example 2. It says graph the line that goes through the points 4, -2 and 7, 4. Find the slope of the line using the slope equals rise over run property. So this is what we would do. We will plot these points. We will go 4 and then -2. And then we will go 7, 4. Okay, now what we want to do, we want to find the slope. So what we could do is rise over run. So we could go here and we can rise. Well, first of all, let's connect these points before we do the rise over run. Now, of course, I would try and do a straight line, but you would actually have a better chance of doing it than I do. Okay, this is not working. Okay, class, I redid this using one of the shapes from this Microsoft Word program. So it would look more like what your line would look like. This is a straight line going through both of the points, the 4, -2, and also 7, 4. So now what we want to do, we want to do the rise over run. So we will have our slope is equal to rise over run. And we will set this equal to. Now we want to do our rise here. We will go up 1, 2, 3, 4, 5, 6. We went up 6, so our rise is +6. And then we will run 1, 2, 3. So our run is 3. So this is our rise. This is our run. Now that gives us 6 over 3. So our solution, we know 6 divided by 3, both has 3 in common. So that will give us 2 over 1. So our slope would be 2. Now we could, if we wanted to, we could do the rise over run again in order to find another point. So what we could do is this here. We could rise another 6, which would be 1, 2, 3, 4, 5, 6. So that would be our rise, and our run would be 1, 2, 3. Now if you look here, this line would actually go through that point as well. So we could take a look at that. Let's see. We can extend this line, and it will go through this point as well. So this is how your rise over run works, because this will be your rise, and this also would be your run. And you can find an infinite amount of points with using rise over run as well. So let's scroll down here, or scroll to the next page. We want to do method 2. And method 2 for finding the slope. If you know the coordinates of 2 points on a line, you can calculate the slope of the line using the formula. Slope equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now this was covered in Math 031, but let's go over this again. Now again, remember, your ordered pairs, the first value is always x, the second value is y. No matter which ordered pair you look at. First value is always x, second value is y. These sub numbers here tell you which ordered pair to get it from. These 2's means that you will go to the second ordered pair. So this is your x sub 2, and this is your y sub 2. The 1's mean you will go to the first ordered pair. This is your x sub 1 and your y sub 1. So now we will go through and substitute. Now we have the formula here. Remember, m also represents slope. So we would substitute. But first, let's write the formula again. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, y sub 2, we know it'll be the y in the second order pair. So that would be 4. Minus y sub 1 is the y in the first order pair. Divided by, we have x sub 2, which is the x in the second order pair, minus x sub 1, which is the x in the first order pair. So we have 4 minus a negative 2, which we know will give us 4 plus 2. And 7 minus 4 we know is 3. So this will give us 6 over 3. So our slope would be 2, because we know both of these can be divided by 3, and that would give us 2 over 1. So now we go down here to example 4. It says graph the line that goes through the points negative 3, 4 and negative 3, negative 5. Find the slope of the line using both methods. Now, first of all, let's plot those points. We have negative 3, 1, 2, 3, and we have 4, 1, 2, 3, 4. So that is our first point. Then we will have negative 3, 1, 2, 3, and then we will have negative 5, 1, 2, 3, 4, 5. Now if you notice here, when we connect these points, it will give us a vertical line. As you can see here, I added in a line here. And if you notice here, after I plotted the points, it gave us a vertical line. So let's try the slope formula to see what happens here. Now we know we have our slope is equal to, let me go back up here and reveal the two order pairs. We have our y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now y sub 2 is negative 5 minus y sub 1, which is 4, all over x sub 2 is negative 3 minus x sub 1, which is negative 3. Now we have negative 5 minus 4, which is negative 9, and negative 3 minus negative 3 will give us negative 3 plus 3. So this is negative 9 over 0, which is undefined. Now in the previous exercise, we know that a vertical line has an undefined slope. So we could go here. Now if we look here, if we go from this point here to this point here, our rise, and let me go here, will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Our rise, we can use rise over run. Our rise would be 9. Now our run, we can't run anywhere, so our run would be 0. So it still would be undefined. So now we move on to the next problem. It says find the slopes of the parallel lines at right. Okay, now we need to find the slopes of these parallel lines. But before we do that, let's go back up to this problem here. Again, the main purpose of us doing this problem both ways was for us to show that we could get the slope using either method. Both methods produce an undefined slope. I know that initially when we did the formula, we had negative 9 over 0. But then when we did rise over 1, we did 9 over 0. But if we would have started from this point, our rise would have went down 9, and that would have made it negative 9 as well. So it still would produce the same answer. So now, let's take a look at this next problem. We want to find the slopes of the parallel lines at right. It would actually be easier for us to do the rise over run. So let's take 2 points. I would say let's take this point here and this point here because they are exact. and then we would do the rise over run.